So the next question is 12th question. Okay, so 12th question, what they are saying whether there will be a displacement if no force is there. Okay, means here they are saying if I'm keeping it here, I'm not applying the force, can it move? No, it cannot move. But they are asking, is there any example where it can move if I'm not applying the force? Yes. How? If any object is already in the motion, for example, you are having a child at home. Okay, so child toys, you have seen the child toy train. Toy train means you are like rotating the key. When you are rotating the key, what you are doing, you are applying the force. Okay, so you are applying the force, so your muscular energy is going inside that toy, and that toy train, in the muscular energy, it will change into the kinetic energy of that toy train, and it will continue to move. So suppose I have started at 8 o'clock, I am asking, okay, I am calling you, come here, and they calculate its force at what, 8:20. So you are not able to find out what is u and what is v. Initial and final velocity you don't know. So in that case, you can find out it on the paper. See, in normal life, you know, there is an example where it can be, where force can be 0 and object is moving. What is the example? Example is toy train. So in toy train, for the force is 0, I'm not applying the force when it is in motion. So force is 0 but it is moving. So how you can prove it on the paper? See, F is equal to ma. A is what? V minus u by t, because it is change in the velocity. Okay, rate of change in the velocity. So what is v and u here? If anything is moving continuously, okay, for 2 hours it is moving, you don't know what is u and v. Both will be same. Okay, so u minus u, they will be cancelled out, force will be 0. But object is moving. No, object is moving, force is 0. Okay, now come to the 13th question. Okay, 13th question. See here, they are asking, a person is there, on its head I am keeping one bundle of hay. So for 30 minutes he is just standing there for 30 minutes. He get tired. Has he done the work? No, he didn't do the work, because angle between the displacement and the force is 90 degree. Then why he get tired? The same question we have done here, that when he was like applying the force on the big stone is not moving, but he get tired. Why he get tired? Because his muscular energy will change into the heat energy, and then heat energy will go into your body, and that will heat your body, and your body will produce the sweat, so that it will be cooled. Okay, that is the same. You can draw the diagram. I told you, you just draw the diagram and it will be good. When you draw the diagram, the examiner will give you the more marks. This you have to continue from this class itself, so that in 10th class you will get good mark. Okay, so see there, F, this is the displacement. You are moving in this direction, but you are applying the force in this direction. Just apply, like imagine that in the 3D. So F and S, the angle is 90 degree. Now the next question is question number 14. What is the question number 14? See, the same thing is there. They are talking about the electric heater. So what is what? Power. See, that's why you have to learn the units. Otherwise, how you can find out this is power? Because W is given there. Na? W is what? It is watt. So what will be it? It is power. That's why it is not written here, na, but it is power. But you can find out, because watt is written here, so it is power only. Okay, they are asking about energy in 10 hours. So what is the formula of power? P is equal to work upon time. Okay, so they are asking about how much energy is consumed. So you know work is equal to energy. So find out work, then work will be the energy. So see here, P is equal to W by T. Okay, W by T. So P is given, T is given. Okay, so what will be work here? Work will be P into T in mathematics. When you will keep it here, send T there to the other side of the equal sign, P will be into T. This is simple mathematics. Okay, when you are shuffling, okay, just changing the letters. Okay, so send this letter here. So what will happen? It is in division, it will become multiplication. W is equal to P into T. So P is there, T is there, W will come. Okay, kilowatt hour. Why kilowatt hour? Not kilowatt hour, sorry, it is watt hour. Okay, watt hour. Okay, sorry, watt hour. Okay, it is watt hour. So work is equal to energy here. Work you have find out. Now they are asking what is energy. They are not asking work, they are asking energy. But you know only this formula of power. Okay, so you find out work, and then work will be equal to the energy. The energy is equal to 15 1000 watt hour. That is the answer. Next question is question number 15. Okay, so question number 15 is what? Illustrate the law of conservation of energy by discussing the energy changes. You have to find out the law of conservation of energy. You have to illustrate means explain it. Okay, explain the law of conservation of energy by discussing the energy changes which occur when we draw a pendulum. Okay, that's about a pendulum we have done in the class 7th. Okay, so we will draw a pendulum. So they are asking, when you are you will hold the pendulum and go to one side. Okay, then what you will do, you will just release it. Allow to oscillate means you have released it, you have just released it. So this is the center. Okay, this is the center, this is the pendulum. Okay, so what you have done, it is a thread, at downside there is a ball. Okay, metal ball. So what is said in this question, you are just holding the ball and you are taking it to one direction. Now what you will do, you just release it. So when you will release it, what will happen, it will come to the center, then it will go to this direction, then again it will come to this. So it will just start to move like this. First go to this direction, means right, then come to the center, then go to the left, then right, left, right, left, unless it will lose all the energy into the air. So when it will lose all the energy, when you are just pushing it here, pulling it here, what you are doing, you are filling the energy inside this, and then when you are losing it, means you are releasing it, what will happen, it will start to move and extra energy it will start to release into the environment. When the energy will become zero, it will come to the rest. They are asking how you will explain the conservation of energy. Conservation of energy means one energy will change into another energy. So it was at potential energy, means it was at rest. Now your body is having muscular energy. So when you will, okay, there are air particles. So when you will move it through air particle, what will happen, you are just putting the energy, muscular energy into that. So your muscular energy will become the potential energy first inside this. So now muscular energy is becoming potential energy. Now when you will release it, it will become kinetic energy, because it is moving. No, first you are just putting it, pulling it and just holding it here. Now you have your muscular energy is going inside it, become potential energy. Now when you will release it, what will happen, potential energy will become kinetic energy, and then kinetic energy will again become potential energy, and it will come to the rest. So that is it. It is what will happen to the energy eventually, all the extra energy, it is having some energy. Okay, so extra energy you are putting, so that energy will go to the air. Okay, and then